Today, Patricio and Leyda Valdez will be showing you how to make a sign change graph. And the reason you want to make a sign change graph is because when you're given the first derivative and the second derivative, you can find how to draw the original function f of x, because by doing the sign change graph for the first derivative, you can find out where the original function f of x is increasing and decreasing. And when you do the sign change graph for the second derivative, you can find where the original function f of x is concave up and concave down. Okay, so let's get started. This is the first derivative given. It's 12t cubed minus 48t squared minus plus 48t. Now what you want to do first is you're going to make it equal to 0, because you want to find the roots. You want to find the roots of the function. So let's make this equal to 0. Okay, now what you can do here is you can factor out 12t. So we're going to do that, and what you're left with is t squared minus 4t plus 4 equal to 0. Okay, now you can factor this out even more. So what we're going to do is we're going to factor it out, and what it comes to is 12t times t minus 2 times t minus 2 is equal to 0. Okay, so now using this, we're going to find the roots of the function. So we're going to make 12t equal to 0, t minus 2 equal to 0, and you don't need to write down the second 2 because same function. So 12t is going to end up to t equals 0, and this is going to equal to t equals 2. So now that you have your two roots, we're gonna draw the line chart thing. Okay, so what you're gonna do is you're gonna take your zeros and you're gonna put it down on your number line. So we're gonna put 0 here. We're gonna put 2 here. Now, the way you find where the original function f of x is increasing and decreasing is you want to know the signs for each of the, like, what it is for negative infinity to 0, 0 between 2, and 2 to infinity. So what we're going to do is we're going to take this function, the function we made equal to 0, and we're going to rewrite it down here. Now what we're going to do is we're going to plug in numbers on the number line between these zeros to find out what the sign is in each of these spaces. So when you do this, you don't need an exact answer, you just want to know what the sign is. Like for here, to get the sign on the left, we're going to plug in -1. So 12 times -1 is a negative number here. T minus 2, so -1 minus 2 is going to be -3, a negative number. Same thing here. So when you multiply negative times a negative times a negative, you get a negative. So you're going to write this down on your line graph. So here the original function f of x is decreasing. Oh, and don't forget, always label your sign change graph. Okay, so now we're going to do this with a number between 0 and 2, so we're just going to choose 1. So 12 times 1 makes a positive number. 1 minus 2, -1, so negative number. Same thing here. So negative times a negative, positive. So here the original function f of x is increasing. Yeah, and you want to label where your zeros are. Okay, so now all we have is one side left here. So to find the sign on the right side of 2, we're going to choose a number like 3. Okay, so 12 times 3 is positive number 36. 3 minus 2, positive number 1. Same thing here. Gives you a positive number. Okay. So now that we have the sign change graph, we know where the original, by looking at this, you know where the original function f of x is increasing and decreasing, because when the derivative is more than 0, so when it's positive, that means that f of x is increasing, and when the derivative is less than 0, that means f of x is decreasing. So here, by looking at the sign change graph, here f of x is decreasing, and here it's increasing and increasing. So now what you know about f of x is that f of x is increasing from points negative infinity to 0, and I'm sorry, it's decreasing from negative infinity to 0, and it's increasing from 0 to positive infinity. Now that we've gathered all the information from the first derivative and the second derivative, here I have written it all down, we're going to start making the graph of f of x. Yes. Okay, so we're going to start with the more basic information, like where it's increasing. So it says that f of x is increasing from 0 to infinity. So we're just going to choose a point around here, and it's just going to be increasing. And here it says that it's decreasing from negative infinity to 0. So we're going to do the same on this side. You see how that's decreasing? Yeah, that's decreasing. Okay. And you know, and as I told you earlier, you know that since it's decreasing from negative infinity to 0 and increasing from 0 to infinity, you know that there's going to be a minimum at t equals 0. So here, I'm going to go ahead and put this in a different color so you know it's nice and colorful. That's going to be a minimum right there. Okay, so now let's get a little bit more specific. Now it says that the graph will be concave up from negative infinity to 2/3. So what you're going to do is you're going to find 2/3, which would be around here. Okay, and it says that it will be concave up. So we got to make sure that all this is concave up, which it pretty much was already. So you know, we just got to make it real. You know, make sure it stands out that it's concave. Okay. So now here it says that it's concave down from 2/3 to 2. So we're going to come back up to our graph. Here's 2 right here. And you know that here it switches from concave up to concave down. These 2 points here. Okay, now you see where this changes from concave up to concave down? Well, that there is a point of inflection. Points of inflection. You gotta know things like this. You gotta find all those important points on your graph, your minimum and your points of inflection. Okay, now let's come back up here. It says that the graph of f of x will be concave up from 2 to infinity. So here, after it's concave down, we're going to switch back to concave up again. And you know that it's got to be increasing. So we're going to do that. Alright then. Well, here again it has another point of inflection because it switches from concave down to concave up. So go ahead and label that. Inflection. Okay, so now using all of the information we gathered from the first two derivatives and the sign change chart, we have created the original function f of x.